without any further ado, our own Thomas Messerschmidt.
Hey, everyone. Good to see you all. All right, we're going to start here. Adding AI to your robots. Science fiction has become science. So everybody knows the robots of science fiction. Here's a few of them.
It seems that he is carrying a message from an Obi-Wan Kenobi.
Everybody knows those robots.
I am Baymax, your personal healthcare companion. I was alerted to the need for medical attention when you said, "Ow."
Model B9, designed
And the original
and
Lost in
computerized as a
Space.
mechanized electronic aid for Earth voyagers engaged in astral expeditions.
And of course, Data from Star Trek. So the question is, are we going to take the red pill or the blue pill? This is a comedy video made by AI, Sora, before they took it down.
If you take the red capsule, you will understand how AI works. If you take the blue capsule, you will continue believing AI is magic.
Okay, how many people here there think AI is magic? So what are we going to build tonight? We're going to take an Arduino, R3 and R4. R3s work, but R4s have the Wi-Fi and the Bluetooth, which is real nice. So then you can use your laptop to do the heavy lifting, and the Arduino itself to control the motors and pull data from the sensors. We're going to add an LED, a servo, the laptop, of course. We're going to connect them through Bluetooth. We're going to add a voice, speech recognition, an LLM brain, YOLO for sight, and then a VLM for better sight. And we're going to talk about vision language action model. So this is a nice infographic produced by ChatGPT. I like it. It's not wrong in too many places. Yeah, I still got a ways to go. Again, we're going to start with that. Let me get my marker out here. Start with that Arduino.
Progress.
Then add LED. Well, I have LED in the servo, so we're going to just unmute. What happened there, Cam?
Is your computer still online?
Let me go back to the share. Give me a second. No, somehow it stopped sharing. I don't know why.
The cam jumping over the other thing back.
I didn't do anything.
All your fault, Cam. You see the share now?
Yes.
All right. You see my picture on the share? Did I share the picture in the corner?
You're in the corner.
Now they're circled, yeah.
Yeah.
Good. Yeah, I was wondering what. All right, we're moving on. So I built this robot called Rosie. You notice the letters R and O and S are capitalized. That's because it's a Ross robot. So this is Rosie. It's based on Amp's MockBot, which, as he said, is based on the TurtleBot. My goal was a little different. I wanted this thing to offer snacks and drinks to everyone. And that's it. Roll around the room, offer snacks and drinks, and then look for people. Go right to people and offer them snacks and drinks. Here's a little demo. It's got the laptop right on the robot. That's a bot bag. Well, by the way, that is running Linux with a GUI. Tkinter for you Python programmers. That's a lot of weight on that. You see it wobbling a little bit. So what is AI? Of course, most of us have been using AI. How many here have used ChatGPT, Claude, Grok, Gemini, or anything else this week? Put your virtual hands up. Show me your virtual hands. Yeah, I see one. Almost all of us have. Everybody's using it. What is it? Few of us know what it is. Fact is, AI doesn't think. It predicts. Trained on tons of data. It finds patterns. And it predicts what's next. Here's a very brief history of AI. Another infographic created by ChatGPT. ChatGPT, that's a tongue twister. In 1950, there was the Turing test. Alan Turing said, can machines think? He figured if you couldn't tell the difference between a computer and a person, that computer program would have intelligence. It was as good. That was passing the Turing test. In 56, we have the birth of AI. The term AI is coined. 66, we have the ELIZA psychoanalyst program. People back then thought they were talking to a real person. They were telling tales of their life. And in the 70s and 80s, we had that AI winter. Progress slowed. Funding was excitement. It dropped to almost nothing. They had all this sci-fi and all the AI was just not meeting it. It just wasn't cutting the mustard. And in 97, we had Deep Blue by IBM, won the World Chess Championship. Things didn't get interesting until 2012 when the deep learning boom started, which was the early beginnings of modern AI. Neural networks began making big leaps in language and image recognition, object recognition. Of course, by the time we get to the 2020s, we have modern AI, which we all know it can chat, write code. Don't forget that write code. You guys are all roboticists. If you're not using AI to help you code, you're not being efficient. This stuff has 5 to 10 times. It's allowed me to have 5 to 10 times the productivity I used to have when I was coding by myself. I mean, I could take 1,000-line program, dump it into Claude, and it can tell me, oh, you have an extra space here. That's why your program's not running. And, we had early ideas, the first AI programs, setbacks, and now we have today's AI tools. I'm going to show you all about those. So for your robot, I've come up with five different flavors of AI that you can add fairly easily. Speech, that's a no-brainer. Chat, text in and out. YOLO for identifying people and other things. Very limited, but we'll move on and talk about that later. And VLMs, vision language models that can look at a picture and tell you what's there. And then the vision language action models. Here's another video for you.
How may I assist you today? I have a certificate. User profile. Would you like help inventing fire?
That's funny. Moving right along. So as we said, we start with the Arduino. Most of us have used Arduinos over the years. The latest Arduino is the R4, or you can use an Uno, R3. Either one will work. But like I said, if you want your robot to be separate from your computer, you're going to use an R4. Otherwise, you'll have to put the laptop right on top of your robot. A lot of people say, well, I can use a Raspberry Pi. Well, you probably can, but most Raspberry Pis don't have the horsepower of a real laptop. We're going to add an LED, which I already did. Add a servo, which I already did. And then we're going to give it the brain.
He always remembers our anniversary, and he never complains about my cooking. After 3 human husbands, that's a refreshing change.
Moving right along. So the brain is the most biggest part of this is going to be on the laptop. Laptops, number one, well, they can have GPUs. My laptop doesn't have a GPU, but it could. I have a secondary laptop that I'm setting up, and that has a GPU. And the difference is what might take 30 seconds to do without a GPU can take 1 or 2 seconds or even less with a GPU. And we're going to see that in a few minutes. I connected the laptop to the Arduino R4 over Wi-Fi. Now you can use USB connected directly. On the laptop, we're going to run text-to-speech, speech recognition, 3 AI models, and the laptop does the heavy lifting. On the Arduino, we're going to send the commands out, well, turn on the LEDs, command the servos, read the sensors, send commands to the DC controller motors. Any hardware you want, you can hook up now to your computer through an Arduino. Like I said before, we're going to use that Bluetooth, and that's already connected. And this is my bridge code, Arduino to laptop bridge code. I'm going to show it here, and then I'm going to give you a quick demo. If it goes too fast, don't worry. I'm going to show you this again. All right. All right, can you pin the robot camp for me? No, I stopped
Yes.
sharing.
Looking for the robot. Hey, John Erickson.
You find it, Cam?
I'm not seeing it. Is it still logged in?
Yes, it is. Hold on. Let me
Oh, I see you. I see you. There. Well, no, that's you. I don't
That's
see
me.
just the robot.
Let me see if I can find it myself. Let's see. Yeah, you know, it moved. I don't know. Maybe it logged off. Maybe I got to log the thing in again.
There was that glitch.
There was that glitch. Oh, there it is. All right. I think that's it. And the camera shut off. So let me turn the camera back on. Oh. Yeah, that's why. There we go. Can you see that cat? You can see the robot there under my other Thomas Messerschmitt cam.
Yes.
Something going sideways. Why is it going
course.
sideways?
Yeah.
Yeah, why is it not going the right way? How about now?
You're
Is
on
that
your-
better?
You're using your phone?
Yeah. I
Okay.
can turn the phone. Where'd it go? I don't see it anymore. Technical difficulties. Well, all right. Well, I'll just turn the phone and see what happens. Anyway. There we go. Anywhere. All right, so there's the robot, and we're going to be testing the code right now. So I'm going to open up my Python in Visual Studio Code, and I'm going to show you that in a minute. And I'm just going to run the code and tell you what's going on the screen, since I can't share both at the same time, I don't think. All right. Oops, I could probably count. Let's see. So we're running the Arduino bridge. And I'm starting it up now.
Thomas, you're saying Arduino bridge. Is this a simple string command to the Arduino, or is it actually running like a ROS topic message?
This is not ROS. This is directly coded from Python. There's a program on Python and a program on the Arduino itself to intercept over Wi-Fi. Let me share my screen. I'll show you the script itself, the program. Just a second. Okay, here's the program. So these are the commands. We're going to set the pin value, with modulation, servo, pins, reading a pin, raw commands, and of course, connects to the Arduino with these codes. And as you go down, you can see it's pretty simple. It's a couple hundred lines of code. We can get a ping sensor, an ultrasonic sensor, everything you can do in Arduino that has an interface for. And now I'm going to run it. I'm going to be just typing the commands in for now. All right, the first thing I'm going to do is turn on the LED. I'm going to put set pin 5 on, which is 1, and hit enter. We should see the LED turn on. There we go. Look at that. Set pin 5 low or off. Whoa. Now we're going to move the arm. Servo pin 4, and we're going to set that to 180 degrees. There you go. And we're going to put it back down now. Servo pin 4. We're going to give it 10 degrees. I don't want to take it all the way to 0. Hey, it works. That was just a quick test. And then move on.
Wait, were you sending that through ROS or through just a serial monitor or what?
I am not using ROS. That is going through Bluetooth.
Oh, okay. All right.
And talking through to the serial monitor, yes. All right, moving on. So now we're going to give the robot a voice. Everybody likes a talking robot. At least I do. I mean, in sci-fi, the robots were always talking. I got to give my robot voices. That's it. So this is how we do it. There's some of the code. We're going to use PYTTSX3. That's the text-to-speech library. We set it up. We set the speech rate, the volume. We can select any voice on your computer. You can actually buy voices for your computer. I've got a few. Windows has at least 2 built-in voices. There's some hidden that you can find. And we're going to just say, hello, I'm your robot assistant. So let's do that. There's the code right there. Pretty simple, 20 lines, or probably less than 20 lines. I got spaces there. Let's try it. Ooh, I got to cancel that one out.
Hello. I am your robot assistant.
Hey, it works. Pretty straightforward. Once you have all this set up, you can just use this to say anything you want. All right, moving right along.
So now anything that would normally be on the screen is just synthesized voice?
We can do that. We can
I have a
synthesize any text.
question.
Is there a
What
yeah.
is this text to speech running on the laptop or on the Arduino?
Run the laptop. All the heavy lifting is running on the laptop. Text to speech on the Arduino, while it's possible, it's not very good, and then it kind of takes over most of the Arduino. I've tried it before. There's hardware too, but this is easier. Another video for you.
My mom thinks AI is magic. She asked me, "Can it see me?" No, mom, it's not Santa. Then she said, "How does it know my birthday?" It posted it on Facebook in 2000.
Moving right along.
So, Thomas, are you using the microphone on the laptop?
Yeah, microphone, camera,
Okay.
speaker. And of course,
Okay.
you can use a remote microphone if you wanted, a remote
But
speaker, Bluetooth.
and I'm stating the obvious. The Arduino is used more for actuating servos and turning on LEDs and stuff like that, right?
That's your motor cortex. It's connecting to all the muscles and the sensors.
Okay. Got it.
It's
The motors and sensors.
It's the spine.
All right, moving right along here. So we're going to use whisper speech recognition put out by OpenAI. It's free. All of this is free. It's a wonderful thing. It's all free. And it installs fairly easily. Some of it takes a bit of time to install, but I'm used to that.
Is this on Windows?
Yeah, this is all on Windows, although most of this can be ported over to Linux fairly easily.
Okay, they have Linux versions of the software, I assume.
Yeah, we can talk. I can send that out on the mailing list at another date. So
Yes.
there's the code. Let's run that. Speech recognition. Here's the program right here. It takes a while to initialize after the first time. It's using several libraries. We're using Faster Whisper, which is a variation of a whisper. This is a language model here. And I added the beep. I want it to beep when it's ready to listen. You can add a wake word, but that's more trouble. After the beep, we record. It's going to record for a couple seconds and then send that to the AI. And the AI will transcribe it. And then it'll print it out at the bottom. So let's do that. You guys see the screen all right? Should I zoom in a little bit?
It's okay.
How do you zoom in on this? Hearings, there we go.
There's
Maybe
also
not.
there's also view options that folks on Zoom could use.
You can
wait,
control
right.
plus usually.
I tried that. Control plus. Wait, there it goes. Control plus. How about that?
Wow.
Amazing. All right, let's run this program. So it's going to take a little while to initialize. So I put that beep in. I didn't know how long to wait.
What's this command line? That's looks like about a 12-foot command there.
Well, that's the built-in command line for Python on VS Code. It's all built in.
So I see your C prompt, and this is buried in that directory, and that is your command there in the quotes.
Yeah, that's just running the program. You see at the end, it's just a path with the program name.
Got it. Ah, I got it. Recognition
Hi
demo.py.
there. I don't know what it's got now. Hello, how are you? Well, let's try it again. Hello, how are you? There you go. It works. The first time I didn't get it because me and Camp were talking at the same time. All right, so this part works. Let's move on. This is with faster whisper. This slower whisper, or normal whisper is what they call it. So we wanted the robots to hear, we want them to think, and we want them to speak. And we want everything running local on your laptop with no internet. Because how many people have been given a demo and all of a sudden you've got an internet and then it's gone? When you get to the venue and there's no internet, or the signal's so weak and shared by so many people, it just doesn't work. Like right now, my computer's telling my internet connection is unstable. And a robot is so much better with an AI mind, don't you think?
Yes.
So next up is adding a large language model for understanding and listening, of course. The LLM, or large language model, is an AI system which was trained on large amounts. I mean, they basically scrape the internet. They put terabytes of data, scrape that internet, and fed it into this LLM, and all of a sudden it learned the patterns of language, and it can predict the next word. That's all it's doing, guys. It's predicting the next word, because if you can predict the next word in a sentence, you can predict the next sentence in a paragraph, and you can predict the next paragraph in a dissertation. When we move on, now we have AI that can chat, that can write for us, that can answer questions, and that can be your science fiction-like AI personality for your robot. You can give your robot any personality with this that you would want. I'll show you in a minute. Again, it's just a prediction system. Statistics and mathematics. Now, one warning. AI hallucinates. You've probably all run into this. AI doesn't know the truth, doesn't know lies. It only knows data that it was trained on. Cam, can you shut that noise off?
Working on it.
Steve. AI only knows data, and thus you have things like this.
It's you. I prefer the term creative hallucinating. Kind of makes sense.
Another Sora video. So we're going to use a large language model called Olama. And to download it, you go to that URL. This will all be in my GitHub. You'll be able to go through all these steps. We're going to pull a model down, which means basically downloading the model to your computer, and then we're going to run it with Python. No cloud, no API key, no cost, no internet. There's the code, at least part of the code. I'll figure the real code in about 30 seconds. So this is the real code. And pay attention to the system prompt. This is where you tell the robot, the AI, that it's a robot. It doesn't know it's a robot. You gotta tell them it's a robot. You can give it a full personality here. You can make it mean. You can make it happy. You can make it silly. Everything you want to have it done. Every kind of personality that you want to give your robot. Now, my robots almost all have personalities. If you want to give your robot a personality, this is where you do it, right here. And here's the chat loop. And we send the message to a llama using this model. We use the system prompt plus the user input. And we get a reply. Look at that, 38 lines of code, including spaces. Not much here. All right, so let's run this puppy. Clear this out.
Sure looks like Linux. Are you sure it's not Linux?
PowerShell.
First time through, it takes a little longer because it's got to load the model. After that, it'll come back a lot faster. And we wait. One of the ways we can get around that is we can send it a prompt when we first launch it, and then have it just wait while we're talking about it. Oh, there we go. Hello, it's nice to meet you. I'm not even reading the screen. What is your name? It doesn't have a name yet. Let's give it a name. I'm not giving a personal name. Well, not yet anyway. Let's give it a personal name. Your name is Robbie. Whoops, can't do that. You're a helpful robot. Keep your answers brief and friendly. Brief and sarcastic. How about that? Right. Save that off and run it. And the first time through is going to be a little slower. Can you see that, guys? Oh, joy.
Yeah, that's cool. That's cool.
He's my assistant. What's on the agenda for today? Can you help me with some dishes? How about dishes? Great. Another human who thinks I'm here to do all the household chores for them. Fine. What's on the agenda? Oh, that's good. That's good. That's what I like. A robot with a sense of humor. All right.
It was Marvin, the paranoid android.
When you want to do that, your answer is brief and paranoid.
That's okay. We need to move along.
We do. You can do that too. All right. Code will all be up there for you guys to play around with. Let's move along. Shall we? And another video for you.
AI says it's trained on the entire internet. The entire internet. Do you know how many cat videos that is?
All right. Now let's give our robot some sight. Yes, let there be sight. We're going to give sight to our robot two different ways. We're going to use YOLO. You only look once. That's more for detection. It'll give you, this is a person, I'm 95% sure, or that's a chair, 87% sure. They'll throw rounding boxes around things. It's pretty close to real time. And in certain situations, it can do like 15 plus frames per second. Moondream, on the other hand, well, it's full on visual language model. You can say, what do you see? And it can tell you all about the scene it sees. And you can say, is there a cat in the picture? And you can say 101 things, but it's slow. It takes, on my computer, it takes about 30 seconds to get an answer. It's best used with a GPU.
Is this to do one frame, one picture, or can it do streaming video?
It can take streaming and then take a frame from that streaming.
I see.
It can't do real-time streaming like ChatGPT can do it, but it doesn't do it well. I've tried that too. I thought I could do navigation with the real-time streaming, video streaming of ChatGPT. It didn't work. It kind of worked, and there was a great lag. Falling behind. It was a second behind. It was 5 seconds behind. It was 30 seconds behind, which makes it unusable. YOLO was introduced in 2015. YOLO means you only look once, not you only live once. That's what it used to mean. You only look once. YOLO is an AI image recognition software that looks at a picture or a video frame, like you said, quickly. I do mean quickly, identifies the object or objects in that picture. It analyzes the whole thing in one pass, where in the olden days, like maybe 10 years ago, it would take many, many pieces. And it's used for real-time computer vision. It detects objects in images or video, like people, cars, animals, tools, furniture, and more. Well, it's got a limit of 80 unless you go to the higher end YOLO, and I haven't tried that one yet. I'll have to give that a shot in the near future. Seeing around the objects gives you a percentage of how accurate it thinks it is. Labels each object, gives you the confidence score. It can detect multiple objects at once. It can track things moving in a video. It can estimate the human pose like that. It can be trained to recognize custom objects. And here's the code. We put the code here in case I couldn't share the other code, but it works. And there I am. It says I'm a person. At least it's about 87% sure I'm a person. That's sure I'm a person. All right. Here's the demo. Let's look at the code first. It uses something called Ultralytics and OpenCV. Most of us know OpenCV. It's been around, what, 20 years or so? 15 years, I think. How long has it been around, Cam?
Long time.
A long time.
Long time. Anyway, we're going to import YOLO. CV2, the camera. Software. We load the model. We open the webcam. We put it in a loop.
15 years passes quickly.
Yeah. And then we get results. We show the frame in the window. All right, let's run the code. Camera error. Oh, this is not going to work. So let's grab the camera, and right now the camera's trained on me for Zoom. So that's not going to work. So I can't show you this in real time.
What was it going to do? Identify you as a human again?
Well, yeah, that's what it's going to do, right there.
All right.
And I did it, there.
We got video.
Yeah, just pretend I did it.
Okay.
All right, moving on. Moving along. So here's our next video. And this is a bunch of self-driving taxis out, I don't know, maybe LA or San Francisco. And they got in a little bit of a jam. I believe this was taken from a traffic camera. I think these are Waymos. Correct me if I'm wrong. Here's the video. I'll play it for you.
That's funny.
Was that about a month ago?
Uh,
Something happened to the network and they all stopped. I remember
what
that.
a mess.
Yeah, the SF cell network crashed for about 5 minutes.
It was a power outage that triggered the outage.
Yeah.
Well, and then when they recovered, it was all, good sir, you go, please. No, 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 please, you go. They just never were able to.
You guys like that one?
That's awesome. Best video yet.
All right. Moving right along. Let's talk about Moondream. Now, Moondream, I found out by asking AI, what's the smallest, best vision language model? And it said, well, Moondream, of course, and it's free. And I like free. Created in 2024. It's only been out, what, a little over 2 years. It looks at an image, and you can ask questions about that image. You can describe a picture, answer questions about a picture, find people or objects in the picture, tell what's happening in a scene, count things, read text, and help decide if something is important in the image, which is really good. I believe it does a few other things, but we'll get to that later. And here's the code. And now we're going to go to the demo. Let's look at the code a little bit. We got to get the camera. We're using a llama. We're going to use Moondream.
Camera open, press quit. Is it using OpenCV as well?
I believe it is. Yes, OpenCV for Python, right here. And a llama.
For the camera.
Yeah, it uses OpenCV to get the camera.
Oh, and by the way, you have to install Python. I'm sorry, Python. You have to install the Python version from their website. It's a fairly quick install. Let's see. Running down here, we got the loop. Grab a frame. Let the camera warm up. Resize. There's an important thing. Without this little line here, it can double the time that it takes to look at an image. So this was real important to do this. It was taking 2 minutes for an image to be analyzed without a GPU again. You save it to disk, send it to Moondream, and here's the prompt for Moondream. What do you see? This can be a variety of things here. It doesn't have to be there. And that's pretty much it. 67 lines of code. Let's run it. Clear. There we go. Okay, I'm going to take a picture of myself holding my coffee mug. Let's see. There's my coffee mug. And snap. There we go. Good night. Oh, we got that image problem again because I'm using the camera for me. Okay. Let me just try shutting off the camera and see what happens. Let me see if I can bypass that. Give me a second here.
Is the goal here for it to identify what it is you're holding? Something like that?
Yeah, I'd like to demo that. Let me try shutting off the zoom camera and see if that makes a difference. Okay, I'm shutting it off. We'll give it a second or two and see if Moondream can connect to the camera now that I've shut off my video. Where's that coffee cup? Let's try that again. Oh, it's okay. Look at that. So this can take about 30 seconds plus, slower the first time. When I run this on my robot, my Rosie, I have it say things like, give me a second, I'm busy. Okay, let me look. And I'm just stalling because it takes so darn long without a GPU.
You could have it be sarcastic, say, hold your horses or something like that.
That's a great idea, Cam.
So
Thank
how
you.
about the miners? Yeah.
And we wait. Thus,
There
the
it is.
reason for
There it is. There it is.
A man is sitting.
Yeah.
Yes. Yeah.
With his hand on top of a coffee mug. That was me. Want to try something else? Here, I've got a car. Let's see if it can. I've got a DeLorean model. Let's see if it can identify the DeLorean model. Little model car. Here's the part where it can say things like, I'm busy. What do you keep bothering me for? Are you bothering me again? Here I am, the brain the size of a planet. I'm standing in front of holding up an old car model.
Yeah. Does your
I
other,
am by the freaking wall.
now that your camera's connected, can you do the other thing where it recognized you as a human?
Yeah, let's do that. Let me
I wanna
cancel
double
this
check.
one.
I want to double check that.
We're going to run YOLO. There we go. See?
What percentage?
89, 88.
Okay. All right.
Look,
We're
it
still
sees a
pretty
cell
good.
phone. It sees my cell phone.
It's probably the R2D2 jacket. He thinks you're an android. Oh, okay.
Yeah,
There you go.
let's see. Can it see this as a car? It says my hand is a person.
Is there a person in there?
No.
Is there a person in the car?
It's not. All right. It says my hand is a person. Let's try this one. It says it's a cell phone.
Well,
It doesn't say it's a car.
Could be.
Well, that's not really a cell phone, but it's YOLO. It's not very good compared to the Let's try my coffee mug. There we go.
Cup. 65%. 65% cup.
Can you teach it? Could you tell it that the cell phone is actually a car?
You can teach it. You can. It can learn new models, new objects. All right, it works. Yay!
Yay!
Let's move on. Yay! Let's move on.
The Husky Lens does all this stuff without any. You don't have to write any code.
That's a good thing.
Yeah.
All right, moving right along. Now, what if a robot could navigate by sight? I researched this about a little over a year ago. I was using ChatGPT's video analysis, and I was taking snapshots and saying, where am I? It was real good at saying, well, you're in the kitchen, you're in the living room, you're in the hallway, you're in the garage. It knew exactly where. And I would then move the camera to another direction and say, where am I now? And it would say, you're in the same room looking at a different direction. I can see a table. It's the same table. It knew where the table was. I said, well, is the table on the left, right, or center? It would tell me. At first, it didn't know, but over the last year and a half, it got so much better. And then I tried the ultimate. Point the camera down my hallway and have it start navigating. It didn't work very well. And that's as far as I've gotten on it. And that's why I thought, yeah, no LiDAR, no ultrasonics, no map, just the camera all alone. And I think it's a possibility. And I think as AI gets better, we can get there because Tesla navigates by camera. Well, of course, they have more than one, I don't know, 14. But if a Tesla can navigate by camera, well, we can do the same. So this slide came from ChatGPT. I did not write this. So it said the honest answer. Pure VLM? No. Too slow for real time. Spatial reasoning is unreliable. Running local will need a GPU. It does, if you want it to be fast enough. Again, I've tried it with ChatGPT, and it almost worked. Keyword, almost. The hybrid approach, sure. Snap a photo, use the VLM to find obstacles, use YOLO to find a person. We don't want to be, knocking over people. Add a LiDAR to stop running into chairs. Get the XY coordinates, feed it to a software path planner, and you get the best of both worlds.
When you say hybrid, what are we combining with VLMs?
Well, we combine VLM with a large language model, and if you really want a lot more accuracy, we can add like YOLO and maybe add a LiDAR. But you don't need the LiDAR, and you don't need YOLO. In theory, moving right along. So the camera would snap a photo. The VLM would say, well, the chair's on the left, the door's ahead, and the table is on the right. But Moonbeam connects, which is really cool.
Yeah, I don't think your slide's advancing, Thomas. Hello, Thomas.
I think Thomas just froze.
Okay. Let's see. Hey, Thomas.
My internet went down.
You're back online?
Can you hear me?
We can hear you.
Give me a second. I got to log in with the other computer. The phone's online.
All right. Well, let's wrap
Can you
this
hear me,
thing up.
Cam?
We can hear you. Go ahead and do whatever you need to do.
And let me connect back to the internet on my main computer here. Give me a second.
All right.
Almost got to the end.
Well, I was going to say it was all going a little too well.
Yeah.
We can see over your shoulder.
Recording in progress.
You there, Thomas?
We're almost done. Okay, let's share my screen and get through the rest of this.
What's your robot's name?
Robbie, real creative.
No, it's fine. Good name for a robot.
I believe I was here before everything went south, right?
Looks good. The hybrid approach.
Yeah, AI sees the world, classic algorithms, and safe navigation for your robots. Another video for you.
My smart refrigerator sent me a notification. You have opened me 11 times in 7 minutes. No new snacks have spawned.
Can you guys hear that?
Yes.
All right. The holy grail of AI for robotics is vision, language, action models. See, understand, act. Sounds simple, right?
Right.
No.
In here, we think and we move motors. We tell the robot, fold the towel, and the robot folds the towel. We tell the robot, vacuum the kitchen, and the robot vacuums the kitchen, or cleans the table, or loads the dishwasher. Right now, there's proprietary code. There's RT2 by Google, not to be confused with R2D2. There's Helix by Figure 1 AI. I'm sorry, Figure AI. And then there's open source. There's Pi Zero by Physical Intelligence and OpenVLA 7B by the OpenVLA team. Now, the VLA acts a lot like an AI agent. A lot of us have been using these agents lately. You start with a prompt or a goal. The AI works through a series of steps to get you there, tries to complete a task. It takes vision and language and turns it into action. The VLA would need glue code to control. Well, it needs something like my Arduino bridge to connect it to the outside world. And the AI agent just uses, email and Microsoft Word or any word processor and spreadsheets. So one is limited to your computer and software. That would be the agent, of course. And with a visual language action model, that would be an AI action model for the real world, for robots. And that's why, I asked the AI, I said, aren't they similar? I said, oh, they're not similar at all. I said, it's got this, that. Oh, yeah, all right, maybe they're similar. I have arguments with AI all the time. All right, one last video.
I tried to automate my life with an AI agent. I made my grocery list: almond milk, tofu, emotional resilience. I canceled my ice cream.
Oh my God, I canceled her ice cream. Okay. Problem with the VLA models is data. When the LLMs were first created, they scraped the internet. They took all that data, terabytes. It's multiple terabytes. I don't know what's big. They fed it into software and found patterns, and thus came up with the modern large language models we have today. But VLAs, the keyword is action. You have to have action-oriented data sets. And there's a scarcity of that. It just isn't everywhere. You have to have video, which is annotated, which has, boxes physically, manually drawn around things to show what's going on. And there's just not that much data. Companies are currently paying people. You can go out there and get paid for training AI. You make little AI videos and they'll pay you, I don't know, $25, $50 a video. So they can bring this forward and bring it to the same level as the LLM, as the large language model. But it's not there yet. That is the future. That is the problem. That is why, a robot can maybe fold one towel dishcloth and it goes, I don't know what to do with this thing. So where are the VLA models right now? Well, they're in the labs mostly, folding, grasping, cooking. You see the videos here and there, but you don't see how many failures there were to fold one towel. You only see the ones that succeed. Open source models, there's a few of them around. How well do they work? I don't know. I haven't tried them yet. On-device models is Gemini Robotics, new last year. And it's not affordable for hobbyists. Well, I don't know. AI wrote this. AI wrote this slide. So, is my internet going to go down again? Anyway, are they safe enough for your living room? No. Is it a general purpose robot helper? Not yet. That's the dream. We are here in the AI revolution. It's early. That's exciting. Oh, my final demo. This is where I put it all together into one program. Let's run that. You still there, Cam?
Yes.
Just making sure I didn't lose you because it said my
No.
was
Losing
unstable.
my seat. Very exciting, Thomas.
All right, we're almost done here. Almost done, Cam. Give me a second here. I run the big demo. This is the big demo. It's voice input, voice output, YOLO person detection, arm control, the whole enchilada right here. Okay, I'm not going to show you the code other than saying, hey, it's, almost 400 lines of code. When did I write this? Last night. Did I write it myself? No. AI wrote most of it, but I spent 4 hours debugging it. One thing I found out about using AI coding is it's real good with small subroutines, small methods. The minute you try to link a bunch of those together, forget it. It's not so good. All right. Still, I got it all done in one night. Here we go. Let's run this son of a gun. There we go. Whisper, running. YOLO, running. Webcam, open.
Hello. I am Robbie. Ask me anything, or to look around, or to move my arm.
Do you see a man? This first time through YOLO, it's going to take
He's standing alone by the park bench, staring at his phone with a look of deep concern on his face.
Lift your right arm.
Extend my single arm to its full height and hold it out to greet you.
Put down your arm. You guys can't see the robot.
I'm looking at the robot on the small screen. I'm not seeing the robot arm move. Let's see if I add a pin. Okay, if you go to the little robot and add a pen, it highlights it. Can you move the arm again?
Right foot, left foot, everybody clap your feet.
Hold on. What do you mean?
Can you have him move his arm again? If you go to the little picture of the robot and say add pin, it highlights it over the screen share.
I was having fun singing along with you, but I forgot my part in the robot arm move.
Okay, let me try that. I'm gonna find it. You can see the robot's video?
Yeah, I've got it pinned. I've got it pinned.
I think I remember it now. Right arm, left arm, everybody clap your arms.
All right, so you got a pin. Good.
I didn't see an arm move though.
Neither did I.
Okay, I'm checking him. I'm keeping you real.
You're right. Don't have an arm to move at all.
What do you see?
Well, the robot's not moving his arm. That's all. I've seen you do it before, but it's not moving it now.
What device is controlling
in my hand, which is actually attached to my single robotic arm?
You're absolutely
Put up your arm.
You're a mistake. Let's fix that. I'm sorry, guys.
Yeah.
Raising my arm.
You provided this.
Oh, I said it moved that time.
What?
It did. And we will call that done. We'll take that.
Right.
We'll take.
Sounds good. Sounds good. We need to shut this thing down.
Wait.
All right, let me finish up the camp a little bit more, about 30 seconds more here. That's the last code. Let me give you the last couple slides and we're done.
I did see the arm move.
Finally. Okay.
Is it cute? Yes.
Is a reboot required?
Summary. We had an Arduino. We had an LED. We added a servo. We added the laptop. We connected them with Bluetooth. We gave it a voice. We used whisper speech recognition. We added the Olama LLM. We used vision language models. And we talked about action language model, vision language action models. And our robot has AI. And your robot can have AI. And all the code is available on my GitHub. I will put the link in after the meeting. Thank you. Now go add AI to your robots.
Thank you very much, Thomas.
I'm doing
This
it
was
right.
an excellent, this was an excellent presentation. Thomas hosts the AI SIG on Thursdays. And we published the link, the Zoom link in the mailing list. Everybody knows where the mailing list is. That's where you get all your robot news. That's where you get all your robot questions answered. I'll put the link to the mailing list in the chat here.
And if you show up on tomorrow, Thursday, I can lead you through any of these things I've done tonight. We can do it right there in real time and get you going on your robot, adding AI. All right, guys, I'm done.